Today I'll talk about comparison of volume of continuous stirred tank reactor CSTR and plug flow reactor. Now here is a problem statement. The reaction A to B is to be carried out isothermally in a continuous flow reactor. The entering volumetric flow rate is V0 is 10 dm³ per hour. Given Fa is equal to Ca into V, for a constant volumetric flow rate V is equal to V0, then Fa is equal to Ca V0. Also Ca0 is equal to Fa0 into V0. Calculate both the CSTR and PFR reactor volumes necessary to consume 99% of A, that is Ca is equal to 1 minus 0.99 Ca0 when the entering molar flow rate Fa0 is 5 mole per hour. Assuming the reaction rate is minus Ra is equal to Kca with K is equal to 0.0001 second inverse. Now here is the given information. Volumetric flow rate is given, V0 is equal to 10 dm³ per hour. Entering molar flow rate is given, that is Fa0 is equal to 5 mole per hour. Rate law minus Ra is equal to Kca with K 0.0001 second inverse. Desired conversion Xa is equal to 0.99. Now initial concentration can be calculated by following equation, that Ca0 is equal to Fa0 into V0. So Fa0 is 5 mole per hour, V0 is 10 dm³ per hour. So that will be 0.5 mole per dm³. Now here this system is a CSTR, so entering molar flow rate that is Fa0 5 mole per hour, Ca0 concentration of A at the inlet, so that is 0.5 mole per dm³, and volumetric flow rate, that is 10 dm³ per hour. Now here in the CSTR, inside the CSTR reaction happen, that will convert A to B. Here 99% conversion will happen in the CSTR. Ra is given, that is Kca, and K is 0.0001 second inverse. Now after 99% conversion, so Ca will be Ca0 1 minus Xa, that is 0.005 mole per dm³, and Fa will be Fa0 1 minus Xa, so that is 0.05 mole per hour. Now here that CSTR design equation, that is V is equal to Fa0 Xa minus Ra. Now here using rate law, Ca is equal to Ca0 1 minus Xa, that is 0.5 mole per dm³ into 1 minus 0.99, so that is 0.005 mole per dm³. So now the rate reaction minus Ra is equal to 0.001 second inverse and into that is K and then Ca. Ca is 0.005 mole per dm³, so that is 0.605 mole dm³ second inverse. Now convert mole per dm³ hour. So now Ra is given, that Ra we calculated already, so that is minus Ra is equal to 605. Then we have to convert mole dm³ per hour, so that will into 3600, so that is 0.0018 mole dm³ hour inverse. Now if we plug that in the design equation, so Fa0 is equal to 5 mole per hour and Xa is 0.99, and minus Ra we have already calculated, that is 0.0018 mole dm³ hour inverse. So finally we will get that V will be 2750 dm³. So CSTR volume required is 2750 dm³. Same thing if we use PFR, now what will be the volume? So let's see here. So given information already we know, and Ca0 we already know. So now here, so these are the input and these are the output, and we have to use plug flow reactor where 99% conversion will be achieved. Okay, so Ca, that will be Ca0 1 minus Xa 0.005, Fa is equal to Fa0 1 minus Xa, that is 0.005, and Ra and K is given. Now here is a PFR design equation. V is equal to 0 to Xa Fa0 minus Ra into dxa. So minus Ra is equal to nothing but Kca. So Kca is nothing but K Ca0 1 minus Xa. So now here if I plug that minus Ra, so Kca0 will be outside of the integration, and 1 by 1 minus Xa, that is dxa, 0 to 0.99, so 1 by Xa into dxa. Now here if I do the integration, so V will be Fa0 Kca0 minus 1 minus Xa, so that is 0 to 0.99. Now if I put that FA0 value, that FA0 is 5 mole per hour, and then K is 0.0001 triple not 1, and that CA0, so here that is in second, so we have to multiply it in 3600, that will be in hour, and CA0 is 0.5, and then minus ln 1 minus xa, that is 0.01. so V will be 5 into 0.1 into 3600 into 0.5 into 4.605, that will give 127.9 dm cube. So now CSTR volume required 2750 dm cube and PFR volume required 127.9 dm cube. That's it. Thank you.